Git isn't hard to learn. And if you've paired Git with GitLab, well, you've just made your life a whole lot easier. All you need to do to become very capable with these tools is a little bit of time. Just give me about an hour or so, a little bit of motivation, and I know you're motivated because you wouldn't be watching this video if you weren't. And maybe a good instructor. And if you put all of those things together, well, you can become very capable with these tools very, very quickly. Hi, I'm Cameron McKenzie. I'm the editor-in-chief at theserverside.com. And I put together this Git and GitLab journey for you so that you can gain the skills that you need to contribute in a meaningful way to your DevOps, system administration, or software development team that's using Git and GitLab. If you stick around for just about an hour or so, I'm going to teach you a variety of things. And I'm going to tell you what I'm going to teach you right now. And I might mention some things that you don't quite know about yet. Don't let that intimidate you, because I'm not only going to explain it to you, but I'm going to make you an expert in these things. Things like, well, creating repositories on GitLab, cloning repositories, managing commit histories, doing Git resets, Git reverts, doing a little bit of cherry picking as well. I'm going to show you how to use the collaborative tools that Git and GitLab provides, doing pushes, doing pulls, doing fetches. I'm going to show you how to do isolated development in Git using branches. I'm going to show you how to create branches, how to merge branches, how to avoid merge conflicts, and how to resolve merge conflicts when they occur. I'm going to show you how to do rebases and show you the difference between a Git rebase and a Git merge. And I just might even show you how to do an interactive rebase and squash. Now, that's not a promise, but I have a feeling we just might get there. But before we do, we need to make sure we've got a couple of things set up already. So I'm going to ask you to do just two things. One, you need a GitLab account. Make sure you've registered for GitLab and you've got your own GitLab account. And secondly, install Git. It's super easy to install. I've got a number of tutorials on how to install Git, but you just have to download it, click the installation, click next on all of the prompts, and boom, your Git installation is done. If you've got that done, if you've got your GitLab account ready, and you've got Git installed on your local machine, well, we're ready to talk about what Git is, what GitLab is, what a Git repository is, and how to create those things and get started. And that is what we're going to do next. Now, people that watch my videos about Git and GitLab usually want to get started right away. And I kind of feel the same way, but I also feel like I can't really start a discussion about Git and GitLab without first just quickly talking about what Git and GitLab is. So what is Git? Git describes itself as a distributed version control tool. And I think that's a good description. It leaves one thing out, and I'll talk about that in a second. But being a version control tool means that Git can take snapshots of your project, snapshots of your files over time. So you write a little bit of code, you're happy with it, you create a commit. You write a little bit more code, you're happy with it, you create another commit. And you end up creating this history of commits, which is like a timeline showing the development of your code. Now, the other cool thing about commits is that you can always go back to a commit. So if you start writing code in the morning and you mess things up by noon, well, if you did a commit when you started the day, you can always go back to that commit and start over again. It gives you the ability essentially to travel through time. I always compare it to a video game, right? Like you're playing a video game and you start the game, you get to a save point, you play some more, you get to a save point, you play some more, you get to a save, and then you die. Right? You don't start at the beginning of the game again, you go back to the previous save point. And that's what commits are like in Git, is the ability to go back to a previous commit when things were working properly, a way to save yourself when you die. Now, the other thing that Git does is it provides a collection of collaborative tools that allow you to share your code with others. So I can create a Git repository on my local machine, and I might have somebody else that I'm working with, and I can allow them to clone my repository to get all of the code, all of the commits onto their machine. From their machine, they can update the code, and then they can push their changes back to me. And then I can get their updates, I can get their fixes, and then I can push my changes back to them. And I can collaboratively do this back and forth. So the ability to manage a commit history and to collaborate and share your code with others, those are two of what I think are the three most important features of Git. The third one is the branching features. Git allows developers to create branches, which are isolated spaces that are separate from the main trunk of development, where they can experiment, take chances, break things. And if they mess up, they just delete the branch and nobody knows that they were doing that. If they do something amazing, they can merge that code into the main branch and then use the collaborative features to share it with other people. And that facility to allow developers to take chances and experiment and be fearless just can't be understated enough. So those are the key features that Git provides. It's open source. It's managed by the Linux Foundation. It was actually invented by Linus Torvalds, the guy that gave us the Linux operating system. So it's got a great and fantastic heritage. Now, that begs the question, what's GitLab? Well, GitLab is that free and open source Git tool put onto a server in the cloud that people can connect to and be charged to use it. Taking open source free software, hosting it in the cloud, and charging people to use it is a fantastic business model. If you ever get into it, you'll likely do well. Now, I'm kind of joking, but I'm kind of not, because that fundamentally is what GitLab does. It puts Git onto a server in the cloud, and then other people can connect to it. This distributed nature of Git is amazing, but it's also difficult to configure. So being collaborative, having a central place where your repository is, and having the features that GitLab provides, like failover and scalability, that is pretty valuable to an enterprise. But fundamentally, that is what GitLab is, and it's not dissimilar to GitHub and Bitbucket. It is Git put on a server in the cloud, and you can connect to it and interact with it just like you would any other Git server or Git repository. Now, I will also say, in defense of GitLab, they also wrap a lot of features around their Git offering. So, everything from security. Git doesn't have security built in. Branch protection rules is something else they have. Workflows. So with Git locally, anybody can commit to the main branch or the master branch. But quite often on a production system, whatever goes into the main or master branch gets packaged and pushed into production. So you want workflows controlling who can push when to the main and master branch. So those are other things that GitLab provides, not to mention the whole suite of tools that helps you do continuous integration and continuous delivery of your code. That's some pretty impressive value add as well. But fundamentally for what we're doing, we're going to see GitLab essentially as Git hosted in the cloud. And that is fundamentally the difference between Git and GitLab. Git is the open source product. GitLab is the vendor who has built an entire ecosystem of tools around that individual Git piece of software. Now, that's the difference between Git and GitLab. The next thing we need to do is actually get into GitLab, and create our first repository. And that's exactly what we're going to do next. Now, after you've installed Git and you've registered for your GitLab account, the next thing you need to do to get started with Git is create a Git repository. And you do that in GitLab by creating a project. When you create a project, a Git repository is created at the same time. Now, a Git repository is a pretty fundamental part of Git. Every time you have a new project, you create a new Git repository to store all of the commits for that project. And a Git repository is a bit more than just a Git commit history. So first of all, the Git repository does manage and maintain your Git commit history. It also manages all configuration information about your environment. It keeps track of all of the branches and the state of the code in all of the different branches. And a Git repository will also keep track of where all of the remote repositories that it can connect to and share code with exist. So that Git repository is a pretty central part of working with Git, whether you're working with Git locally or working with GitLab. So what I want to do right now is actually go into GitLab and create a new project. So I'm going to click on this Create Project button. I'm just going to create a blank project. I'm going to give it a name. I'm going to call it My Project because I like to project positivity as much as possible. It's going to be a public repository. I always like throwing a README file in it. And then I'm just going to click Create Project. And that will create my Git repository on the GitLab server. Okay, and there you go. We've got our repository on the server. Now, if you want, you can go up here and you can add files. I'm going to add a new file. So I'm going to click New File here. I'm going to add a new file on the server. I'm going to call it alpha.txt. I'll do hello world because that kind of seems like the requisite thing that you're supposed to do. You can do a commit message, say something like my first commit. And then finally click commit. And now I've actually committed this file into this Git repository on GitLab. Notice the branch name is main. When we work with Git locally, it usually creates a default branch called master. We're moving away from that. So all of the GitLab, GitHub, Bitbucket, they now create a branch called main instead of master. That may cause us a few problems a little later when we try and bring the two together. But for now, it's just worth noting. We've got the main branch, and that's probably the way we're going to do it going forward. So there you go. We've now got a file on our project. It's called alpha.txt. You can even see there's a commit ID for the commit. Every single commit that we have in Git has a unique identifier associated with it. Now, we can create files up here on GitLab, but generally speaking, you write files and you create files in your local file system, right? You have a web project, an HTML project, a Python project, a Java project, a JavaScript project. You're using an IDE or an editor to write and test files locally. So we've got things working up here, but what I want to do is I want to bring this project down to my local file system. Now, how do you do that? Well, as I mentioned, we're going to start working with these collaborative Git tools. When there's a repository on the server and you want to bring the files from that repository on your local machine, you do a clone. Now, in order to do a clone, you need to know the unique identifier that GitLab has assigned to this particular project, to this particular repository. Fortunately, it's not hard to do. You see that beautiful blue button there that says code. Just click the drop down, look at the HTTPS option to clone it, click copy URL, and then come down to a folder on your file system. I got a folder called _repos. Just right click, select open Git bash here. If you've installed Git, that should be available. That appears after installing Git. If you don't see that, you may not have Git installed. But open Git bash here, and then you just say git clone. And I'm going to paste in that URL. Learn GitLab Fast is the name of my account. My project is the name of the project. I'll click enter and keep your eye on that right-hand side there, because when I click enter, boom, all of a sudden I get a new folder on my file system. It's going to ask me to sign in. So I'm going to sign in with my browser right here. I'm going to authorize using Git Credential Manager. So that's good. We know that all of the authentication happened well. By the way, sometimes if the authentication using OAuth isn't successful, you may have to create a GitLab token to authorize. Or you may be forced to do SSH. A lot of organizations require their users to have an SSH connection. I've got separate tutorials for both of those, and it's nuanced stuff. So if you're having a problem, go check out those tutorials. Hopefully you're able to log in right away. I've got success. It's cloning into my project. I'm going to open up my project right here, and you'll notice, boom, I've got all the files that are up on that server. I've got the README, and I've also got the alpha.txt file. Now, what do you do locally? Well, you add files, right? You do work. I mean, this is your repository to write code, to write software, to do your cloud native computing, JavaScript, Python, Rust, I don't know. I'm just going to add files. Git can keep track of any files. And I'm just using txt files just to keep things simple. But I'm just going to add a new file, right? So I'm going to add bravo.txt. So bravo.txt has now been added to my repository. One of the commands you want to get used to is Git Status. And right now, if I move into my repository, right? So right now I'm not in that project. I got to cd into that project. So cd my project. And if I'm inside that project, by the way, you know you're inside the project that's been cloned if you can see that .git folder. It's a hidden folder, but if you've configured your environment to view hidden files, you'll see it. And any folder that's got that .git folder in it, well, that means it's being managed by Git. But I'm going to do that Git Status command now that I've moved my command prompt into the folder, into the My Project folder. And you can see it says bravo.txt is an untracked file. So here's something about Git you should know. When you create a file in a project that's being managed by Git, Git is kind of hands-off. It says, you know, there's a good chance maybe you don't want me to track that file. Maybe that's a temporary file. Maybe it's a scrapbook file. Maybe it shouldn't be part of the project. So if you want Git to track any files that you put into your project, you have to what we call stage those files or add those files to Git's staging index. Basically tell Git, hey, I want you to manage and keep track of this file. And you do that simply by saying git add, in this case, bravo.txt, which will add bravo.txt to the list of files that Git will include in the next commit. In fact, if I do a git status command here again, you'll see it says, hey, there's a new file, and that's going to be committed the next time you issue a commit. So the Git index now lists bravo.txt. Well, it's talking about the next commit. Why don't we do a commit? Git commit -m. That's what, the second commit. Boom, all of a sudden we now have our second commit. It's in there, it's good. And if I do a git, do a git log one-line command, this will actually show me a log of all of my commits. So there was the initial commit when the Git repository was created on GitLab. There was that my first commit, which happened when I added alpha.txt. And now there's the second commit where I've got bravo.txt. Now, here's something to note. I've got Bravo on my local file system, but if I go over to GitLab and do a refresh, Bravo's not there. So even though I cloned from GitLab, as I work locally, those files aren't synced together unless I explicitly ask for a sync. And one way to take my files and push the changes that I've got locally to the server is to do a Git Push. And that's exactly what I'm going to do here. I'm going to open up a command window. I'm already in the project here. I'm going to say Git Push origin. Origin is just the name that we give to the server we're connected to. So GitLab in this case is the origin. That's where we originally cloned from. I'll say git push origin, and assuming all of my authentication is in line, those files will get pushed up to GitLab. Now, if I come back to GitLab, it looks like it's made me a liar because it's only alpha. I'm just joking. I got to do a refresh. So I do a refresh, and boom, all of a sudden bravo.txt is up on the server. So you can see, if you actually have files on the server or repository, you want to get it locally, you do a clone. You do some work locally, you do your commits after adding files to the index. If you want to push that back to the server, which essentially means making it available to other people on your team, you do a git push. Now, after a git clone, if you want to get future updates, what you do is a pull, possibly a fetch, but we're going to look at a pull right now. And so let's say somebody else went into this repository and added a file. I'm going to add a new file here. I'm going to call it, well, I'll call it charlie.txt. Hey, Charlie. I'm going to call this the third commit. commit those changes. And now my project's got these 3 files in it, Alpha, Bravo, and Charlie, but I don't have Charlie on my local file system. So again, it's all out of sync. So how do you fix that? Well, you go to your terminal window, you go to your command window, you go to the Git bash shell, you say git pull. Now, keep your eye on the prize over there. See what happens when I do that git pull command. Boom, all of a sudden now we've got charlie.txt on our local file system. So you do a clone the first time you want to get the files from a repository in the server into your local machine. Every subsequent time you want to do that refresh, you do a pull. Optionally a fetch, which I'm going to show you in just a moment. But let's add another file here. I'm going to use the touch command to add devo.txt. Now, the touch command is just something I like using at the command line. It's just a simple way to create a file at the command line. You can see over there, boom, devo.txt gets added. If I do a git status, it says, hey, you got to add that to the git index. So I say git add. If you want to actually add anything new in the current folder, you can just do git add dot. And that says add everything in the current folder or subfolders that's new or changed. You have to add something to the index anytime you change it or anytime you add a new file. But if you update a file, you got to add it to the index as well. And now let's do a commit. Git commit -m. Fourth commit. And by the way, -m means message, right? Every commit has to have a message associated with it. So git commit, what's the message? -m fourth commit. And now that creates that 4th commit for me. But again, that's not on the server. I can refresh all day long here on the server. Devo is not going to go up there. I've got to do that git push and push that file up. Now, after I do the push, boom, all of a sudden we now see devo.txt on the server. Now, I did mention that there was something called a fetch. When you do a pull, what happens is the updates come from the server to your local repository, and then Git will look at your working directory or your working tree, all your files that are local, and try and put the new files onto your file system. Sometimes you don't want to do that. Sometimes you just want to get updates about the changes into your local repository, but maybe you're working on something in the middle of something. Maybe you just want to compare what you've got to what the changes are. In that case, you can do a fetch. A fetch will let your local repository know about the latest changes, but not actually write those changes onto the files in your folder. If you want to actually get them onto your folder, you have to do a git merge command. Let me show you this. Okay, so I'm going to add a file to the server. I'm going to call it echo. So a new file called echo.txt. Echo. Okay, what is this? I'm losing track now. Is this the 5th commit? Commit those changes. Again, that's now on the server, but it's not on my local file system. Now, maybe I want my local system to know about these changes. I have that information in my local Git repository about the updates on the server, but I don't want to disturb maybe the work that I'm doing in my local file system. In that case, you can do a fetch. So watch this. I'm going to Control L clears the screen. I'm going to do a git fetch. And boom, it's going to say, you know what? Yeah, there's some changes up there. I'm going to bring them down, right? Unpacking objects, doing all this stuff. But you notice that echo.txt is on the server, but it's not refreshed on my local file system. It's not there. So information about the changes has been brought down to my local repository with a fetch. But unlike the pull, it does not actually write those changes to my local directory. Now I can actually say, hey, Git, you know what? It's time. Bring those changes in. I can say, hey, Git, merge my local workstation with the files that you brought down from origin. So this is the first time we're going to see the merge command. You usually see it with branches, but this is a slightly different use case for it. I want to merge those changes you got with the fetch into my local file system. I click enter, and it says git merge, not something we can merge. Let me just do a git fetch, and then a git merge. Okay, so there we go. We didn't like the git merge origin. Git fetch, and then git merge, and now you can see, hey, we've now added this echo.txt file right down into the file system. So there you go. That's how easy it is to do a fetch and then bring that code down. I guess I didn't need to put origin in there. So there you go. That's kind of how that works. So again, when you're working with Git and you've got a repository in the server, you want to bring it locally, you do a clone. After that, you add files to your local repository, you do a git add, you do a git commit, and then you can do a git push to send those files to the server. Now, by the way, there's actually a way to simplify things if you've edited a file. So for example, like right here, if I've got echo.txt and I want to add another echo, so I've made some changes. Git status says there's a couple of changes that need to be staged first and then committed. You can actually do a staging and a commit at the same time when a file's changed. You can't do it with new files. You can say git commit -a -m updated echo. And now when you do this, it's going to do a commit, and it's also going to stage any files that have changed since the last time a commit happened. It won't work for new files, but for any files that have changed, right? I updated echo. It'll actually do the git add and the git commit at the same time. So that's a little trick. But yeah, after you've done that, then you git push and send your changes to the server. Maybe changes have happened on the server. If that's happened, you do a git pull. That will take the changes on the server and bring them right down to your local file system. Alternatively, if you don't want to overwrite what's on your file system right now, you can do a fetch. And then after the fetch, you can do a git merge a little bit later on. But there you go. Those are the collaborative tools that we use with Git and GitLab. That's how we share code, make changes, push changes to the server, get updates from the server, and just work collaboratively with others. It's pretty awesome. Okay, in the previous tutorial, we started off with a GitLab repository, cloned it, worked with it locally, and then pushed back to the server. I want to do the opposite this time. I want to start locally and then do a bunch of commits, do a bunch of changes, and then push those changes back to the GitLab server. So take an existing project and then push it up to GitLab. Now, in doing so, I also want to introduce you to some other important commands that you need to know if you want to be effective at Git and GitLab. And so I put together this presentation here to kind of talk about and step us through some of the important commands we use when we're doing local development with Git. So anytime you want to work with Git, you have to create a repository. Every project that you work on should have its own repository. We saw how to do that over on the server with GitLab. If you want to do it on the local file system, you just create a folder where all your project files are going to go, and then say git init. When you do that git init command, what happens is in the folder in which you issued that command, you'll see a hidden .git folder be created. Now it is hidden, so if your operating system isn't configured to show hidden folders, you won't see it. But there's all sorts of interesting plumbing in there about how Git is configured and branches and commit history. Again, we don't want to spend too much time in there, but it's interesting to know that it is there. And that is essentially the bytecode embodiment of your Git repository. Now, once that's created, what we do is we start adding files to that repository. I like using the touch command from the terminal window. The touch command, if a file exists with the name that you're trying to touch, so touch alpha.txt, it'll change the timestamp on it. If the file doesn't exist, it just creates a new one. You don't have to use touch to create a file, but it's just one way to do it at the command line. But if I was to issue that command, well, a new file would get created. It just gets put onto the file system right next to that Git folder. Now, if I want Git to track that file, I have to add it to the index. So I have to do a git add alpha.txt command, and that then moves the alpha.txt file into the Git index. I shouldn't really say moves it into. The Git index is just a file that keeps track of all of the different resources that Git is supposed to keep track of itself. But doing the git add command stages the file, adds the file to the Git index, adds the file to the Git staging index. Now, when you're happy with all the files that are part of that Git staging index, you can do a commit. Now, in a lot of these examples, I do one commit after adding one file, but you can add 10 files and update files and edit files and delete files and add all of them to a single commit. I'm just doing kind of one file, one commit at a time, just for the sake of simplicity. Now, we do that commit, we create that first commit, and now we've got a commit in our commit history. You'll also notice there's a commit ID there. Every commit gets a great big long hash code, unique number to uniquely identify it on that good old Git blockchain that you're maintaining locally. Now, after that, you just keep adding files and updating files. So touch Bravo txt adds the file. Then you do the git add Bravo txt so that it's now tracked by the Git index. And then you want to do a commit, and then you say git commit -m second commit. And now we've got a second commit, and that second commit is now including Bravo in the snapshot. And our file system is essentially the sum of all of the Git commit histories put together. Okay, so let's now create another one. So you know where this is going, right? Touch charlie.txt. That sounds a little unchristian, but we're not going to, I'm leaving it at that. Git add charlie.txt to add charlie.txt to the index. Then we do the git commit, and our git commit history keeps adding up and moving on and on. And as I said, I'm doing one commit, one file each time here, but you know, we could go in and edit alpha.txt. So you could edit something at the command line. You can just do this command echo hi greater than alpha.html. I don't mean to confuse you by command line commands. That does the same thing as opening up the file, typing hi in and saving it, right? Just easier to show it at the command line like that. But that would update alpha.txt. It's not a new file, but it's an update. Then at the same time, we could add devo, are we not devs? Then add devo and alpha.txt to the Git index. Notice right there I did git add dot. The dot says add anything that's changed or anything that's new that's in this folder in which the command is being issued and subfolder. So it's like a way to do it all real quickly. And then once you do that, well, after you've done that add, you do a commit, and then all of those files now get added into that next commit, right? And then our local file system is just the summation of all of those commit histories added up. And so that's sort of how a Git commit history works. Now, the other cool thing is we can start doing really cool operations on our history. So for example, maybe Charlie and alpha.txt change and the devo.txt aren't working for us, and we want to go back in time. Well, we could say git reset --hard, because it's never easy, and give the commit ID of bravo.txt. And if we issue that command, a couple of things happen. One is the git commit history moves back to bravo.txt to where that commit happened, ID 26F149. And all of the changes, all the files that happened and all the changes that occurred after that commit will be reversed out. So we issue that command, boom, we end up going back in time and those files get deleted. In fact, the change to alpha.txt that happened in that fourth commit would be removed as well. So probably we should take away that star from there because it's actually going back to the way it was right at the beginning. Now, by the way, it's --hard. --hard means don't not only move the pointer of the current commit history back to bravo.txt, but also clear the index and change all the files on the file system as well. The hard does it right. It does everything at once. But that's the idea of managing your Git commit history, how you can maintain a Git commit history, and also how you can start manipulating that Git commit history with commands like git reset. Now that's a little bit of theory. Let's actually do this example in code and see exactly how it works. Okay, let's put that theory into practice. I'm going to create a new folder on my file system in the _repos folder. I'm going to call it history, I guess, because we're going to be dealing with a Git commit history. The idea, of course, is, these folders are representing projects. It could be a Python project, a web development project, a Java project, I don't know. But you've got some project you want to track its files. So what you would do is you would create a folder for the project. And then you go in and you open the Git bash shell, the born again shell. I guess bash includes the word shell, so saying it again is redundant, but whatever, old habits die hard. And then I say git init, right? Because it's better to get in it than to get out of it. And when I do that, you'll notice that .git folder gets added over here. I might even view this and do some large icons there. If I go in there, you can see head, description, config, remote references, objects. This is where all of your Git commit history or information about how to connect to remote repos, what the different branches are, what's added to the index, all of this information is stored in here. This is often referred to as the plumbing. And we don't want to get too involved with the plumbing. We want to stick with the porcelain, not the plumbing. So it's good to know that that's there. That's what gets added when you do a git init, but we want to just focus on, building our application. So how do you do that? Well, you come in here and just create a new file. I'm going to create a file called alpha.txt, right? I'm going to keep that common trend, right? And do a git commit. Well, I can't do a git commit. I got to do a git add, right? Git add dot git commit -m, first commit. All right, there we go. Now we've got a commit in our git commit history. If I do a git log --oneline, you'll see there's really only one commit in our history. Even creating the repository wasn't registered as a commit. We need to create a little bit more of a rich commit history here. So I'm going to, I'm going to touch bravo.txt. That creates the file. Boom, you see it there. Then git add dot and then git commit -m, and I'll call this, what is the second commit. So you create the file, you add the file to the index so that it's staged, so that Git knows to keep track of it. Then you do a commit, and that takes a snapshot of the file and permanently saves the state of that file as part of that commit in the Git commit history. I'm going to do a couple more. So I'll touch charlie.txt, git add dot git commit -m. That's the third commit. By the way, Control L clears the screen. And why don't we touch devo.txt, git add, are we not men, are we not devs, and then git commit -m, fourth commit. There we go. We've got a nice rich git commit history here. And one command I really like, they call it git log a dog. So git log gives you a log of what's happened. I don't like git log because it's busy, right? Like this doesn't look good to me. So no thank you, :q to get out there. Git log --oneline. Look at that, looks beautiful. There's also git log --all decorate. That'll put some asterisks next to it. --oneline --graph. It doesn't look that great right now. By the way, one of the things I don't like about Git is you have to type the commands in correctly. But that's called git log a dog because it's a mnemonic, right? ADOC, all decorate one graph, a dog, git log a dog. It looks better if you've got a divergent commit history, but you get the idea. We've got a nice git commit history here. Now, one of the things we can do after we've created a git commit history is we can manipulate it a little bit. So let's say everything messed up after Bravo, and I want to go back to the way things were at bravo.txt. Well, you can just do this. You can do a git reset. Oh, you know what I need to do? I need to git reflog. Reflog's like log, but it shows you just what's kind of configured local. It might show you some stuff that others might not see if you shared your code on the server. I also like the format of reflog a little bit better. But you can see that second commit has a commit ID of 6D80C52. So I can say git reset --hard, and let's reset back to 6D80C52. I'm going to just double checking. Now keep your eye on the prize. Watch what happens over in the files in the file system when I click enter. boom, all of a sudden Charlie and Devo are removed. I've now reset myself back in time. If I do Git Log Oneline, it looks like those commits are gone, right? The log's saying I've only had 2 commits, the first commit and the second commit. And you're like, no, there's a third and fourth commit, but the log's not showing it, right? We've reset back to that second commit. And as we've done it, the tool's actually manipulated and managed our file system by deleting files off the file system. Now, I mentioned that Git reflog sometimes shows things that maybe Git log doesn't. If I actually do Git reflog, it actually shows you that fourth and third commit. Git doesn't get rid of stuff. Once it's in Git, it is in Git practically forever. It is not easy to purge stuff from Git, I assure you. So that fourth and third commit are there. The Git log doesn't show it. The Git log is kind of what other people would see if they cloned your repository. Git reflog is all the dirty history that you've got in there. It's the stuff you might not want people to see. Now, the question I often get is, well, are those commits gone forever? Right? Like, what if I now decide, you know what? It was actually Charlie I wanted. Well, you could just do a git reset -- hard back to the third commit, which is 12c 5deb. Click enter, keep your eye on the prize. Boom, charlie.txt comes back. Maybe you say you didn't want to reset at all. So you do git reset -- hard 2bb5510. And now we're back to the fourth reset again, right? The fourth commit again. Alpha, Bravo, Charlie, Devo. See, we're just quickly manipulating our commit history. Like it's amazing. Like you manage those commits and then you've got the ability to go back to any commit in history when you do that. So super cool. Now, that was the git reset command. There's another command that people confuse with git reset called revert. And I want to show you what revert does. Now, with the reset, we reset back to Bravo. And when we reset back to Bravo, it removed all of the files that happened after that Bravo commit. So it removed Charlie and Devo. So git reflog, let's take a look. Now, git revert, people think git revert will do what git reset does. But git revert, what it does is it surgically goes into the commit that you give it and removes the changes associated with that commit. But it doesn't affect commits subsequent to that commit. It doesn't affect commits prior to that commit. So for example, on the second commit, we added bravo.txt. When we reset back to bravo.txt, it got rid of Charlie and Devo. But if we actually just revert that commit, it'll actually get rid of bravo.txt. Watch, the second commit is 6d80c52. So I'll do a git revert. And I'm going to revert 6d80c52. It's going to ask me to provide a git commit message because when you do a revert, there's actually a commit that gets registered in the git commit history. I'm just going to click :Q to accept the default and get out of there. But you can see, boom, all of a sudden, bravo.txt is gone. So the revert actually surgically removes information from the individual commit. I could even go git revert. Let's get rid of that alpha.txt. So what was the first commit? That was 6c7331d. No commit is safe when I'm behind the keyboard. Again, :Q to get out of this nasty Vim editor. By the way, you can set Notepad++ as the editor to come up there, and instead of doing :Q to get out of it, you just close Notepad or Notepad++. It's way easier that way. But the default is Vim, so I'm using that in these examples. But now you can see, we reverted that first commit. Now, revert surgically removes a commit. There's actually something called a cherry pick. And what a cherry pick will do is it will bring a commit back. It will take what happened in a commit and pull it into your branch. That's usually something you use across branches, but I'm going to show it to you here. We reverted a couple of commits. Maybe I want to cherry pick that first commit back. So I can say git, let's cherry pick that first commit, that commit 6C7331D. I believe that was the first commit. And Git will say, okay, I'm going to create a Git commit message. So you got to provide some info. But notice my repository is just Charlie and Devo. I'm going to cherry pick that first commit. And boom, all of a sudden alpha.txt comes back. I actually thought it was going to ask me for a commit message and it didn't. So life is good. And if I actually take a look at the Git Log Oneline, okay, you'll notice that the reverts are listed in there. It's also the first, second, third, and fourth commit are listed there. And it looks like it, when I do that cherry pick, it lists the name of that commit as the message for that cherry pick. So that's kind of interesting as well. I actually thought it was going to ask me for an actual message. Yeah, so there you go. So that just kind of gives you a good idea and a good overview of how all of these different commands work when you're working with Git. Now we've got all these files on our local file system, but they're not tied to a repository on GitLab. And that's what we want to do right now. We want to be able to push our local project up to GitLab and create a repository for these files up on the GitLab server. So how do we do that? Well, we head over to GitLab and we create a new project. I'm going to create a blank project and I'm just going to call it my-history. Now, I'm not going to put any files in it. I'm not going to initialize it with a README. I'm not going to do anything like that. Just create a basic project. I'll make it public just to make life easier, but this will work public or private. I'm going to create this project. And then it's actually going to say, you know what, there's nothing in this repo. So if you actually want to, connect an existing project, this is what you need to do. And so it gives us the commands here. It says, okay, make sure that the initial branch is main. I'm going to come over here. Notice that the branch is master, Git Status. You'll see on branch master. We actually want to use main because that's sort of the default for GitLab. So it gave us this instruction to do git init -- initial branch equals main. Oh, that's not what we want. That's not going to work. I think what I need to do is say git branch --M main. And now that will actually change the name of my local branch from master to main. So that command wasn't up there, but I had that in the back of my head. Now, after you've got the branches on your local repository consistent with what's on the repository that we just created, we need to tell our local environment about that remote server we want to push to. And that's called adding a remote reference to Git. And that's the command here, git remote add origin, GitLab, blah, 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 blah. And I come over here and I paste that in. Now, by the way, it's git add origin. Instead of origin, you could actually just say GitLab. Origin is the convention. So origin kind of represents the server that we originally cloned from. Usually the server that we're pushing back and forth to, we usually give it the name origin. But that's just a name that's made up. We could say GitLab, and the next time we push, we go git push GitLab. Next time we pull GitLab. So I'm going to call it GitLab. You can leave it origin if you want, but that should do the trick. Now, what's the next command? It says do all of your commits, and then finally do this. Git push, but set the upstream branch that you're going to push up there to main. Now, I didn't call it origin, I called it GitLab. So git push -- set upstream, GitLab main. So push that main branch up to the server. Click enter. Hopefully all of your authentication is in order. It says a new branch was created. We've now pushed up to main. I'm from Missouri. I want to see this. So I'm going to click on the My History project, do a refresh, and there we go. Boom, all of a sudden, Alpha, Charlie, and Devo to match Alpha, Charlie, and Devo, which are there on the file system. I successfully pushed an existing project from my local file system up to GitLab after doing all of those git revert, git reset, git cherry pick, git init, git status, git log, and git reflog commands. So there you go. I told you Git and GitLab isn't hard to learn. Just got to give it a little bit of time, be a little motivated, be a little patient, run these commands, get some time behind the wheel, and it's all going to come into place. Okay, that was awesome. The next thing that we're going to talk about is one of my favorite parts of Git and GitLab, and that is isolated development in branches. That's next. So the next thing on our agenda is branching with Git. Branching gives developers the ability to break away from the main branch or the master branch and create an isolated development environment for themselves where they can create files, update files, change things, delete things, take chances and experiment and, maybe come up with something brilliant. And if they fail, they can just delete the branch and nobody is the wiser. Now, branches are a mildly complicated concept. So Darcy DeClute, her book, Scrum Master Certification Guide, is behind me right there. She put together some visuals for me here to help us visualize how branches work. Now, just imagine you do that git init command. You create a brand new repository. You start off with the main branch or the master branch. And, well, initially there's nothing there. So, I don't know, what do? You add a file. You can do the git touch, you can do the touch alpha.txt and git add, then do a git commit like we did on the previous examples. And then after you do the git commit, you've got your first git commit and you've got a file alpha.txt in that main branch, right? That all makes sense. Now, let's just say somebody wanted to experiment a little bit. They didn't want to mess up the main branch. But at the same time, they kind of want to take the files on the main branch and play around with them a little bit, break things, be courageous. So what a developer can do is a developer can create a new branch and then switch onto that new branch. So here's one command, git switch -c dev. That says create a new branch called dev and then switch onto that branch. So the user can issue that command that creates a new branch called dev. Now, initially, main and dev are exactly the same when that new branch is created. Both dev and main at this point in time are pointing at the same commit, right? You just said, hey, there's a commit there, I like it. I want to experiment with it a little bit. Create a new branch off that commit point, okay? And so that new branch is created. But when the branch is created, the main and dev are pointing at the same thing. But then, you can add a new file to dev. So touch bravo.python. You can see bravo.py now gets created in this dev branch. It's not on the main branch. And you can do a git commit, make it your second commit. Now, the dev branch has two files in it. The main branch only has one. And in fact, you could go ahead and then maybe even create another file, create charlie.python, add it to the git index, then do your git commit, your third commit. And now dev's got three files in it, charlie and bravo.python, alpha.txt, and the main branch only has alpha.txt. So now the developer could delete those files and delete the development branch and nobody's the wiser. While the developer's actually doing this, maybe somebody's actually updating the main branch as well. Maybe there's some fix that's gone into the main branch. So maybe even the developer themselves is doing that. So you could always switch back to that main branch, do a git switch main. That now takes you from the dev branch onto the main branch. And now the files on your workstation, if you did that switch onto main, you'd only see alpha.txt because the main branch only has alpha.txt. It's that other dev branch that's got Bravo and Charlie Python. Now, just imagine this. Maybe the developer on the main branch is going to add devo.txt, add it to the staging index, do a git commit. And now all of a sudden we're really in trouble because the main branch has devo.txt and alpha, and then dev has Charlie and Bravo and alpha, but it's all out of sync. So now what do you do? Well, this isn't necessarily a bad thing. Maybe the developer working in dev is thinking, I've done something brilliant here. And I know the people working on main in parallel have been updating things and fixing things. That's great too. But I'm going to take my changes and merge them into main. So in this case, a developer would switch onto the main branch. So git switch main, where we currently are. And then they would issue this command here. They would say git merge dev. So you're on the main branch, and then you say, what I want to do is I want to merge all the files from the dev branch, into main. And when you issue that command, watch these files move. The files that are in dev move over to main, and then a new commit happens, that merge commit, which indicates that, we've actually had some files move over here when we've merged the state of that dev branch with the main branch. And so after that merge, the main branch has Devo, Charlie, Bravo, and Alpha in it. Now, what's in dev? We merged dev into main, but we didn't merge main into dev. So right now, dev, the last status of dev is that third commit. If we were to switch back to dev, it would take us to that third commit where we'd only see Charlie, Bravo, and Alpha, right? We haven't actually merged the files in main, which in this case would be Devo, into that dev branch. So a lot of people miss that. A lot of people think that when you do the merge, both branches get synced. But no, you're on the master branch. You merge the files from dev into master. That only brings the files from dev into the master branch. Doesn't do anything with the files in the master branch and putting them into dev. So there you go. That kind of helps you visualize how branching works in Git. Why don't we do exactly this on the file system with our Git bash tools doing this Git branching and Git merging? We'll do that next. Okay, let's demonstrate branching and merging on the file system with a new project. I'm going to create a new project here. I will call it acquisitions because we've got mergers and acquisitions happening here. And I'm going to open up the Git bash shell and just type in Git init because, again, it's better to get in it than to get out of it. That gives us our Git repository. And what I want to do is, well, I'm going to start off by just creating alpha.txt, adding it to the Git index and doing a git commit-m and call it the first commit, right? Okay, so now we've got a commit on our branch. We're on the master branch. The master branch is the only branch that we have right now. So why not create a new branch? I'm going to click Control L to clear the screen and say Git branch and call the branch dev. So then that now creates a branch called dev. I'm still on the master branch. If I did git branch -- list, you'd see there's a dev and a master branch. To move on to that dev branch, I can say git switch dev, and boom, now I'm on the master branch. Now, by the way, I think in the example I did git switch -c dev, which switches you on to the dev branch and creates one at the same time, but there you go. 6 of one, half a dozen of the other. But I'm on the dev branch right now. And if I do an ls command, you can see that I've got the alpha.txt file. And you just look at the file system. There's our folder, alpha.txt. So let's add another file. Let's go and add, well, what have we been doing lately? We have been doing touch bravo.txt. So now we've got Bravo, git add dot git commit -m. That's the third commit, right? Okay, now we've got Bravo over here. Let's do touch Charlie. Sounds unchristian, but here we go. Git add git commit -m. That's our 1, 2. Is that our third commit? I think I got the third and fourth commit, so I'll call that the second commit, although that's not the second commit. Git Log Oneline is going to be confusing as anything. But you get it. The second and third commit happened on the dev branch, although that happened out of order. The first commit was on the master branch. Now we've got Alpha, Bravo, and Charlie on that dev branch. But watch what happens if I git switch back to the master branch. What do you think is going to happen? So keep your eye on the prize. Boom. All of a sudden, Bravo and Charlie disappear. So they're still in the Git repository. They're just on that other branch, but that branch is isolated from the main branch. And let's just say, I don't know, maybe the main branch had a fix come in. So touch devo.txt, that's the fix. Always is, are we not devs? Git add dot git commit -m, that's the fourth commit. That is the fourth commit. Okay, and now if I do a git reflog, we can see the history. More importantly, if I do git log --oneline --all -oneline -decorate -graph, it should be all decorate one line graph, git log a dog, that's the mnemonic ADOG, that's how you remember it. But when I ask it to do a git log and kind of create a graph, you can see, there's that first commit where dev and master were pointing at the same thing. Then dev splits off to that second and third commit, and then the master branch branches off to that fourth commit. And now we're in a situation where we need to bring all of that together. So how do you do it? Well, I'm on the master branch. I've only got Alpha and Devo, as you can see. I want to bring in those other two files. How do I do it? Well, I say git merge dev. And that's going to merge dev into the master branch. That'll bring in Charlie and Bravo. I click enter. Boom, you can see those files added. I do :Q to accept the default git commit message and exit out of Vim. And boom, all of a sudden we can now see I've got those files. If I do a git log a dog again, notice how we've got that merge point. So you can actually see how we've gone from the files in dev have sort of merged into that master branch. But at the same time, notice it says dev is still only pointing at that commit that has Charlie and Bravo. If I do git switch and move onto that dev branch, dev's not going to have Devo. Boom, Devo goes away. And that's because we merged dev into master. We never merged master into dev, right? But we could. I'm on dev right now, git merge master. Nothing says we can't, right? Boom, now we merge that in. We've got devo.txt on our file system as well. Let's see if we can do that git log a dog right now. Okay, and there you go. Now it says that dev and the master branch are both pointing at the same commit. Previously, dev and master were pointing at different commits. Now it's pointing at the exact same one. That means they're in exactly the same state. And so there you go. That's how you create branches in Git, how you switch between branches in Git, and also how you merge branches together in Git when they potentially get out of sync. Now I just demonstrated how to create branches and merge branches together using Git. You can actually do all of this up on GitLab as well. Now you don't usually code your entire project on GitLab online, but a lot of times you'll get branches in and need to merge them together. And that's what I wanted to demonstrate right now. I'm going to go on to GitLab and I'm going to create a brand new project. And I'm just going to create a blank project, call it Olive, because we're going to deal with branches, Olive branches. I don't know, it'll be private, maybe have a README in it. I'll create the project and boom, all of a sudden we now have this nice, simple project created for us. I might even go so far as to add a file to it. So I'll click this plus button, create a new file. You know what I'm going to create? I'm going to create alpha.txt, do the commit on this file, and boom, all of a sudden we've got alpha.txt as part of our Olive repository. But we've only got one branch, right? So we've got the main branch right there. But you can create branches on GitLab. I'll just say new branch, and I'll create that dev branch. Because there we are. Boom. I'm on that dev branch. And I'm actually going to copy this URL, move it into this second window so that you can actually see we've got the main branch on the left-hand side and the dev branch on the right-hand side. And right now, they're both pointing at the same commit, 88F6CC70. They're both in the same state, right? But let's go over here and add a new file onto dev. So we'll call this bravo.txt. Bravo. And then do this commit. I'll accept the default messages here. And now, if we look at that Olive project and we look at the dev branch, we've got alpha and bravo here. But if I refresh over here on main, I've only got alpha, right? The two are out of sync. And I can make this worse. I'm going to make this a lot worse. Alpha, bravo, Charlie. Charlie. Wake up, Charlie. Going on an adventure. Okay, so now the dev branch has two files in it, Bravo and Charlie, and the main branch only has one. So we are out of sync. Even I can do refreshes all day long. It's not going to help out. Then I can make it even worse over here. Now over on the main branch, I can create a new file and we'll call this devo.txt. Are we not devs? And over here, we'll do the commit. And now, like, as I said, we've now got that situation which I characterized before where we've got two branches, the main branch and the dev branch. The main branch has devo.txt, which the dev branch does not, and the dev branch has Bravo and Charlie, which the main branch does not. And now we have to consolidate them. We're even getting messages here, right? Hey, you pushed to dev just now. Do you want to create a merge request? So the tool is actually telling us, you know what, you are out of sync and your different branches have different code in them. That's not the end of the world, and that's not necessarily a problem, right? Like that's just part of normal branch-based development in Git. But a time does come when you need to merge them together, and that's exactly what I'm going to show you next. So as you can see, dev and main are out of sync. And I need to take the files from dev and bring them into main. So when we're working with Git, all we had to do was just do git merge. But when you're working with a tool like GitLab, there's a workflow. And remember, there is the possibility that when you're working with GitLab, the stuff that gets merged into the master branch may be part of a continuous integration or continuous deployment pipeline that automatically pushes into production. So you don't want to give everybody the ability just to merge into the main branch. Typically what happens is junior devs have to create a merge request. And so I've gone and opened full screen here so I can see this merge request option. And I'm going to go in and create a merge request. So I click on merge request. It says, do you want to create a new merge request, Cameron? I'm like, yeah, I do. I definitely want to create a merge request. Well, it says, what do you want to do? Well, I say, I want to take that dev branch and I want to merge it into the main branch so that the main branch is going to get all of those files in dev. I then click compare branches and continue. So this is going to make sure that this is possible. Sometimes you get conflicts. Everything looks good here. I'm going to say, let's create that merge request. So the merge request gets created. And now there's a merge request that goes out. It might actually go to a senior developer. Now I'm the only person on this project, so the merge requests go back to me. But somebody else who might be senior will look at this and say, yes, you know, this code looks good. I approve this, and then we'll merge it. Or they might reject it and say, no, there's some bugs in there. It's not quality enough. I'm happy. I want this merge to go through. There's a beautiful blue button there that says merge. I'm going to click merge. And now all of a sudden, all of those changes that happened from that happened inside that dev branch are now going to go onto that main branch. So let's head back to the Olive project. I'm going to head over into my main branch. And now you can see Alpha, Bravo, Charlie, and Devo have all been merged into that main branch. Now, however, again, if we were to go in and take a look at that dev branch wouldn't have all of the same commits in it. Although actually here, as part of that merge request, we also deleted that dev branch. And by the way, that's something that you typically do with topic branches, right? After a temporary branch has been used and you've merged all of the code in, you may as well go and delete that temporary topic branch because you've got all the changes. No point having that ugly branch history and branch structure floating around. Now, there is one way to get around that, and that is to not merge code, but to do a rebase instead. A lot of people get intimidated by the Git rebase and prefer the Git merge. I'm telling you, a Git rebase isn't that difficult to understand, and that's exactly what we're going to do next. You know, there's a few things people don't like about branches. People don't like having this disjointed history where things branch off. That upsets some people. There's another problem with this sort of merging approach, and it's the fact that we end up with this superfluous merge commit. Right? No work happened in that merge commit. No files were changed. No files were added. No files were deleted. It's just like a marker commit, right? And it's just kind of bookkeeping, right? It doesn't represent anything that's done. So there's an alternative to a merge which achieves the exact same result. Okay? The exact same result of bringing files, say, from dev into main like a merge does. It's not a merge, it's called a rebase. And so it achieves the same result, but it plays around with your history a little bit to give you a linear history and eliminate that superfluous merge commit. So here's how it works. I would go onto the main branch, and previously I would say git merge dev, and that would take the files from dev and merge them onto main. Instead, I would say git rebase dev. And when I say git rebase dev, well, things start to change. So first of all, what ends up happening is we end up going to that very first commit where we created that dev branch. Now, when we actually created the dev branch off main, off that first commit, when we first create the dev branch, main and dev actually are pointing at the same commit. They're both pointing at that first commit. It's not until we do that second commit exclusively on the dev branch where they get out of sync. When we do a rebase and we're on the main branch and we say, let's rebase dev onto main, what we do is we take the commits on that dev branch and we just put them on top of that shared main dev commit that we started out with. So all of a sudden that second commit is no longer part of that exclusive branch of dev. Now it actually just gets put on top of that original first commit. And now main and dev, both for the first commit and the second commit, are the same. We then get the files from dev pushed into main for that second commit. So if anybody ever went back to that second commit, both dev and main are exactly the same right there. And then that third commit, the same thing happens. We rebase that third commit onto the main branch. So for the first commit, second commit, and third commit, well, main and dev are exactly the same. We don't have any divergent dev branches. And you can see actually the files in main and the files in dev for first, second, and third commit are all the same. As Git is rebasing, you can see that main is getting all the files that it would have got with a merge. Now here's the thing. That third commit remains part of dev. So dev is now pointing at that third commit. So dev still has Charlie, Bravo, and Alpha, which is exactly what it had when we did the merge. But the rebase then takes that fourth commit and it puts that fourth commit on top of the third commit, which was put on top of the second commit, which was put on top of the first commit, which was a commit that was shared both by main and dev. You can now see dev has been rebased onto main. Okay, so main and dev are the same all the way through to that third commit. And in fact, if you looked at the files in dev, you would see that the files in dev are Alpha, Bravo, and Charlie, everything up to that third commit. Now, with the main branch, we've got that fourth commit, and that fourth commit is now stacked on top of that third commit. So it almost looks in history like the first, second, and third commit happened, and the fourth commit happened after that. And it doesn't just look like that. That's what the history is telling you has happened. We've now rebased dev onto main, and then taking the commits that happened in main and then put them back on top of dev. We're now given a linear commit history, and that superfluous merge commit is no longer there. So we've solved the problem of the branching and divergent history, and we've got rid of the superfluous commits, all by doing a git rebase instead of a git merge. And one other thing that's worth mentioning, that third commit is where dev points to. Dev is now pointing at that third commit. Okay, it's time to do a git rebase. I'm actually going to do a git rebase on my local file system, and then I'm actually going to do a git rebase on the server that's going to include a push, a pull, creation of a new repository, and a pull request and a rebase as well. So that's going to be wrapping everything up together in a bow. But I'm going to create a new folder right here, and I'm going to call it my rebaser. Okay, and I'm going to go into that rebaser project and open Git Bash here. Do a git init, and then give me just 1 second. I'm going to create a git history of 2 branches with alpha, bravo, where it needs to be merged or rebased together. So just give me 1 minute. Okay, here we are. As you can see, I've got my rich Git commit history here. I've got a dev branch, I've got a master branch, and you can see the divergence. And I want to merge dev into master, but I don't want that branched history, and I don't want an extra commit representing that merge commit. So the option is to do a rebase. So I'm on the master branch. I want that second and third commit added to the main branch, the master branch, and those second and third commits were from dev. If I do an ls command, you can see I've only got alpha and devo locally, not bravo and charlie. So what I can do is I can do a git rebase and rebase dev onto this branch. I'm going to move this file here so you can see the files on the file system right there. So we're going to rebase dev. It now says, hey, we successfully rebased and updated the references. So now you can actually see that we've got all of the files in dev. I'm going to actually open up a new Git bash shell here, just so that I can do the Git log all one line decorate graph, Git log a dog. Actually, Git log AO, okay, I messed up the order there, but you get it. Click enter, and now look at that. There's no longer this disjointed commit history. We've now got a linear commit history, first, second, third, fourth commits. That fourth commit was put on top of the second and third commit. And we have a beautiful Git commit history here with no superfluous merge commit that didn't do anything other than just track an operation that didn't affect files. So there you go. Don't be afraid of the rebase. It's just a way to keep your commit history clean. Okay, let's take a look at how a rebase would work in an actual repository. I'm going to create a new folder here, and I'm going to call this folder linear because we want to create a linear history instead of doing merges. And I'm going to do the requisites here. So I'm going to open the Git bash shell, and I'm going to say git init to initialize a repository. And I'm just going to put that first alpha.html or alpha. Make an HTML file in there. So now we've got one file we need to commit, git add dot, git commit -m, first commit. Okay, and you know where we're going here. Now at this point, I've only got one branch, master. I can say git switch -c dev, which will create the dev branch and put me onto it. I can even say dev git branch all. You can see I've got the dev branch and the master branch. The star indicates that I'm on the dev branch. But right now the dev branch and the master branch are the same, right? They both got alpha. But let's change that. Let's add beta.html. Add that and commit it. Okay, and then let's touch Charlie.html, git add dot, git commit -m, third commit. I got the order right this time. Okay, now let's switch back to the master branch. Git switch master. And notice when we switch back to the master branch, Beta and Charlie are going to disappear. Boom, they are gone. Now, let's really mess things up. Let's add devo.html to this particular branch, the master branch. Git add, git commit -m, fourth commit. Okay. And now we've got a real mess of a git commit history. Git log what is it? A dog all decorate one line graph shows that well, we've got the dev branch with a couple of commits, we've got the main branch with a couple of commits, and we want to bring them all together. Now previously what we would do is we would say git merge, and then that would maintain that branch history and add a new commit. Instead, I'm going to say git rebase dev, and now this is actually going to take dev, put it on top of the main branch, put the commits from the main branch on top of dev, which is on top of main, and create a nice linear history. Watch this. Git rebase, successfully rebased. You can see that extra files, boom, were added to the folder there. So now that master branch has got all of the files from that dev branch on it. And if I do that git logging of a dog, you can see that that disjointed history is no longer there. Everything has been brought back together. You'll also notice that that dev branch is a little bit out of sync with the master branch. So the dev branch still only points to that third commit. So if I come over and I say git switch onto dev, well, you notice that the dev branch doesn't have everything from the master branch. And that's because we rebased dev onto the main branch, onto the master branch. We didn't rebase the master branch onto dev. So at this point in time, we still have divergence between the different branches, master and dev. Dev has 3 files, master has 4, but we're in the state that we want it to be in, which is master has all of the changes from dev inside of its folder. It no longer has a divergent branch history, and there's no superfluous commits for merges. And there you go. That's how a git rebase works. You know, you can't talk about the git rebase command without talking about squashing commits and taking your git commit history and compressing it a little bit, tidying things up, making it look handsome. You can see I've got a number of files in this repository here, and I've also got a number of commits. And let's say I wanted to squash all of these commits down. So I've only got a history of a couple of commits here. Here's how you do it. You can say git rebase, git rebase -I, do it interactively. And I'm going to put in C8D4DAF. That's the first commit. So I'm going to rebase back down to C8D4DAF. And all of a sudden, this window comes up, and I've got the ability to pick which commits I want to leave alone and which I want to squash. I'm going to leave that second commit, but I'm going to pick that for a squash. And then I'm going to pick that for a squash as well. I'm going to squash the life out of that one. Oh, and Fred is not spared. So now I squash all of those commits. I got to commit this file. So I got to click Escape, Control W to write that file, and then :Q to get rid of it. Now :Q exclamation mark to really commit out of there. And now all of a sudden you can see that when I do that git reflog command, or even the git log Oneline command, boom, all of a sudden we've smashed that git commit history down. Rather than having 7 commits, well, now we've only got 2. That's how you squash your git commit history. Okay, you can't talk about merging files or rebasing files without also talking about the possibility that you'll get a merge conflict. A merge conflict happens when a file is in 2 separate branches and people are working on it at the same time. And you try and merge those branches together, and Git's like, I don't know how to fix that. Like, 2 people wrote code at the same time in the same file in 2 different branches. You want me to figure it out? It's like, not going to do it. So let me show you how to create a merge conflict and also to fix one. So I'm going to create a new folder, and I'll call this peace because we want peace. And in this folder, I'll create a new repository. So I'll open up my Git bash shell here, say git init, and touch alpha.html, git add git commit -m first commit. And there we go. We've now got one file in our repository, and it's named alpha.txt. Now, let's say I go over to the branch called dev. So git switch -c dev to go onto the dev branch, and I go in here and I look at this alpha file and I say, hey, you know what? I'm actually going to edit this file. And I'm going to say, welcome to my awesome website. Okay, no problem, right? Git add, git commit -m, awesome edit. Okay, so we've got that commit, right? Now let's go back to main, git switch main. Git switch master. Okay, now I'm on the master branch. Now from the master branch, we're going to go and open up alpha.html. And of course, on the master branch, we haven't made any edits to alpha.html. Right? So they were made on the other branch. Or maybe someone will come in here and say, you know, hey, this is a great and fabulous website. And now they've changed this file in this branch. So on the dev branch, it says this is an awesome website. And in the main branch, it says this is a great and fabulous website. So I come in here, I say git add git commit -m, fabulous. Okay, and now maybe I want to merge everything together. I'm going to do a git log -oneline -decorate -graph -all. Okay, so you can see we've now got 2 commits. It's branched out. I'm on the master branch. Let's merge dev in. So git merge dev. Let's bring dev in. And let's see what happens. Merge conflict in alpha.html. Automatic merge failed. Fix the conflicts and then commit the results. And you can see it now says master : merging. Like even the git bash shell is telling us that things don't look good. So what do? Well, we have to go in and fix it. So I got to go in and find that file. I'm going to edit it. And you can see Git's telling me, hey, this is what was in dev. And that's what's in the current branch, which is the master branch. So I don't know how to fix it. Fix it. You know, like 2 people worked on the same file at the same time, right? I don't know what, is it fabulous? Is it awesome? Is it great? I don't know. Just fix the darn thing, right? And don't have people working on the same file in different branches at the same time. Like get your team lead to figure things out. So, I mean, you just got to come in here. I mean, this is code. This is a real mess, right? Because you got to worry about compilation and stuff. This is a great and fabulous and awesome website, right? So Control S to save the file. Now git add to add the file, git commit -m. Fixed it up. Now that merge is complete. And if I do the Git Log Oneline, you'll now see that those 2 branches have been merged into one with the new updated file based on the fact that, yeah, I had to fix things up because people were working on the same file as separate branches. So that's what a merge conflict is. It's when people work on the same file in separate branches and Git has no idea how to merge them together. How do you fix it? We just got to go into the file and resolve it. Right? Figure it out. Get those 2 people together, put their heads together and fix the darn thing. Best way to fix a merge conflict is to not have them in the first place. Well, there you go. That's your merge conflict. Okay, let's put all of these pieces together and add a few more pieces and kind of replicate what might happen the first day on the job when you go in and are given a Git repository to work with. Well, we're first going to need a GitLab repository on the server. So let's say there's an existing project and I don't know, maybe you're working for the CIA in Black Ops and you've created a project called Black Ops. They've created one for you. It's got a README, some files in it, who knows. We'll create that project. So you're going to get onto a project and I don't know, the team lead's probably busy and you're going to say, hey, what can I do? And the team lead will say, just, you know, here is the URL for your GitLab repository. Just go poke around there, see if you can find some bugs and fix them. So you type in that GitLab repository there. You look for this blue button that has the GitLab URL on it. You copy that, you go to your local repository and, well, you clone it, right? So you open up a Git bash window, you say git clone, you clone that repository, and now you bring everything from Black Ops down to your local file system. Okay, now, right now, if you were to actually go in here and take a look, you would see that you're on the main branch. And you're going to get fired if you start doing work on the main branch. So you got to create your own topic branch, right? A temporary branch that you do your own work in that probably you're going to delete after you're done with. We refer to that sometimes as a topic branch. So let's create a new branch. So it is git branch -c to create, and to create that branch, we'll just call it dev. Again, right? We'll create a dev branch. Right? We're kind of just following a pattern here to reinforce these ideas. Now you notice we're still on the main branch. We'd have to say git checkout dev in order to move onto that dev branch. Now, checkout's an older command. It's been replaced by switch. Checkout kind of is used for SVN and older version control tools where you would check something out and no one else could access it because files would be locked. We don't have concepts like locked files in Git. I think they had the checkout term to make it easier for people that were using older version control tools to adapt. But really, we just use Git switch now. That's the preferred one. But I thought I'd show that to you because if you look at some older tutorials, you see that used all the time. The point is it achieved what I wanted. I am now on that dev branch, a separate branch. And now I'm just going to add a new file to this branch, and I'll say, you know, touch alpha dot, I don't know, make a Python file, right? Alpha.python, maybe beta.mojo. Mojo is the new programming language that's going to replace Python. I'm really big on Mojo. I got a bunch of tutorials on those on my YouTube channel, so check them out. And now we'll do a git add, do a git commit -m, and say that's my first commit. And there we go. Now we've got a little bit of a commit history and some files added to the repository. Who knows? Maybe we fixed some bugs. Maybe we created some amazing Mojo or Python algorithms, and we want to show this to the boss, right? We want to show them how great our work is. So now we have to push this back to the server. A couple of things. So we don't want to merge this into main. We want the tech lead to do that. But we do want this dev branch to go back to the server. Now, it's actually going to be a problem because it's one thing to clone a branch and then push back to that branch. It's another thing to clone a repository and then create your own new branch and then push that back. So watch, if I do a git push origin here, it's going to say, you know what? You're on a dev branch, and the only branch we know about is main. So you're going to have to do things a little differently this first time around. And I'm like, okay, I can do that. So git push origin head : dev is what I want to push up. I'm going to type that in. I was going to say, okay, we can do that. That looks good. So now we've actually pushed this new branch up to the server. Okay, well, let's head back to the server. So we do a refresh here. And we can see that, well, we've got the main branch and there's also a dev branch. So the tech lead's going to be very happy that you weren't working directly in main. You at least made it to lunch today. So congratulations on your first job. Now, what do you want to do? Well, you want the boss to see your work, right? So maybe you're going to create a merge request. And you can actually see this option to create a merge request right up here. If that option isn't available to you, you can always click over here to create the merge request as well. And so I can come over here and say I want to create a new merge request. What do I want to merge? Well, I want that dev branch of mine to be merged into that main branch. Now again, I could have done this on the command line and then pushed the changes to the main branch up to the server. If there's branch protection rules, that may have got rejected. If there's no branch protection rules and they're continuously deploying applications from the main branch and I put a bug into the system, well, I'm not going to be invited back for a second day. So you do these merge requests. So I can do a quick comparison if I want, make sure that there's no errors in there. You notice that you can assign people to the merge request. You can assign reviewers. I'm not going to worry about that. I'm just going to click create merge request. Notice you've got the option to delete the source branch when the merge happens. I'm going to deselect that because I'm not necessarily interested. I want to keep that dev branch around, but I'll create that merge request. And now the next time the team lead or whoever logs in or whoever got assigned to that merge request comes in, well, they're going to open up their tool and they're going to see, hey, there's a merge request that's waiting for me. So they'll click on merge requests and they'll take a look at all of the merge requests that are open for them. They'll click on the merge request and then, I don't know, maybe they'll take a look at some of the commits, dig around a little bit, see what happened there. And then finally, if they think that it's good, well, they'll approve it and then merge that into the main branch potentially. And then all of a sudden now, if we actually go back into that main branch, well, boom, we'll see the main branch has README, but it's also got the alpha Python and the beta Mojo files in it as well. And there you go. That is the basic round trip, right? You clone your repository, you add some files, you stage them in the Git index, you do a Git commit. When you're happy with your Git commit history, you then push back to the server, maybe even having to worry about that upstream, that new branch being pushed up to the server. And then maybe you do a merge request and then your boss takes a look at the files and hopefully merges them into the main or master branch. And in fact, you might even be using something like Git Flow, where you actually don't do a merge request into the main branch. There's actually might even be a buffer branch, like, a specific development branch that your topic branches go into as well. I've got a couple of other tutorials on Git Flow and GitHub Flow and GitLab Flow if you're interested. But I think that's beyond the scope of this. But there you go. That's a bit of an overview of how you would use GitLab from the server to the client, back to the server, with some workflow wrapped around that GitLab pull request. It all looks pretty cool. Sorry, GitLab merge request. That's what they call it. Pull request we see more over on the GitHub side. And there you go. That's kind of how a round trip works. Here's a little trick that I forgot to mention. It's the Git Stash. Sometimes you're going to be working in your repository and you'll create a file. So what, C, D, E, F. So I'll touch Fred. Hope Fred doesn't get upset with me touching him like that. I've added a file. Now I'm going to do a git add command. And now if I do a git status, you can see that file is ready to be part of the next commit. But let's just say I'm like, you know what? I need to do a commit, but I'm not happy with that file. I don't want to commit that file. But at the same time, I don't want to delete that file because there's good work in it, right? So one of the things you can do is you can stash your changes in Git. I can say, you know what, Git, stash everything that's currently in the index. And they'll say, okay, I'm going to stash it. You notice it takes out Fred, and if I do a git status, there's nothing to commit. I can now do a commit, and that file there is not going to be part of the next commit. It's kind of been removed from my workstation, but it's actually in the stash. And at any point in time, I can go back and say, hey, those files that I put into the stash? Pop that back onto my workspace. And so I say git stash pop, and look what's going to happen over there. Boom, Fred comes back. If I do a git status, you can see Fred is ready to be staged. If I do a git commit -m and say, hey, Fred, that now gets added to my git commit history. And there you go. That's how the git stash pop works. There's also a git stash apply, which you can use alternatively to git stash pop, but you get the idea. If you got changes that you don't want to delete, but you don't want to make them part of the commit, just do a git stash. So there you go. That Git and GitLab tutorial gives you a whirlwind tour of how these technologies work together. Now, admittedly, that's not everything that Git and GitLab has to offer. I mean, with GitLab, there's branch protection rules, there's security. You can even get into continuous integration and continuous deployment with their DevOps tools. But of course, that's beyond the scope of just working with Git and GitLab together. And I mean, I guess there's other stuff with Git too, but we covered a lot of that Git porcelain. I mean, I guess you could talk about Git smudges and stuff like that, but I think we covered everything that you're really going to use on a day-to-day basis with Git, and even a lot of commands that you may not see too often. Now, if you did enjoy that tutorial, a couple of things I would say. One, subscribe to my newsletter. I've got a newsletter where I keep you up to date with the latest on Git and DevOps and containers and artificial intelligence. So the link's in the description. So please sign up for that. Also, if you're interested, I've got a number of books up on Amazon. I wrote one called Pickering Springfield, all about the origin of the fictional city of Springfield in The Simpsons. And also I've been working with a young freelancer named Darcy DeClute, and she wrote this really awesome Scrum Master certification guide. I can't recommend it enough. So if you're working in Scrum, or somebody working in Scrum and they're interested in gaining a Scrum Master accreditation, that book is going to make it happen. So again, links in the description. If you're interested in my personal antics, I would encourage you to follow me over on Twitter at CameronMCNZ. And also, if you enjoyed this tutorial, please recommend it to some of your friends. I work really hard on this, and I would like more people to just get passionate about Git and GitLab through this tutorial. Finally, I mean, you're probably watching this on YouTube. If you are, subscribe. And I am the editor-in-chief over at the server side. Head over to the serverside.com. We got lots of great content on Git, GitHub, GitLab, Bitbucket, DevOps, Agile, Scrum, Java, Mojo, artificial intelligence and machine learning, you name it. But in the meantime, have fun working with Git and happy GitLab.